Okay. All right, so according to my notes, we left off on this particular slide. Tie rods connect the center links to the steering knuckles. Again, on a parallelogram system, we got a center link, pitman arm, idler arm, that's shifting back and forth. Tie rods are then bolted onto the center link, and that is the link between the center link and the steering knuckle. Okay, so again, the whole idea behind this is that we are taking a rotational motion of our steering wheel and we're converting it to reciprocal motion, left to right and back and forth, depending on how we want to steer this thing. Tie rods are going to end up being mounted to the steering knuckle through a ball joint. Okay, so here's a tie rod end, an outer tie rod end specifically. Okay, it's got a ball joint, so this thing is able to shift back and forth as it's moving, so that way as it's going up and down, it can still be attached while still allowing for movement or the actuation of that suspension system. Okay. Now the fun thing about these tie rod ends, more specifically these ball joints, is you can see right here there's kind of this little bit of a shaft right before it starts to get to the threaded areas. The shaft here is tapered. Okay. So as this fits into the steering knuckle, it gets wedged in there. Now we do have a nut here that's put on the threaded portion of this that is torqued to specifications, which is obviously going to create a clamping force. But even if something were to happen where this were to fall off, that is being wedged in there, so it's being held in place just through friction alone. So sometimes removing these or taking these out of the steering knuckle can be a little tricky. You have to have a special tool to be able to do that. Normally the tool holds onto the steering knuckle and then pushes up on this threaded portion to kind of essentially pop that out. Now there are some tricks that we can use to be able to do that. Again, we got all sorts of fun little tie rods. This one's frozen up. That one ain't moving. But you can see here the condition of that boot, right? If I'm going into a vehicle and I'm doing an inspection and I see that my tie rod end ball joint that's connected to my steering knuckle is in this kind of condition, I would definitely recommend replacing it because, again, salt, water, dirt, grime, all that sort of stuff is going to get into this ball joint and create it to cause rust and issues, and it's going to seize up. Okay. Now, again, keep in mind that we obviously have thousands of pounds that are going to be moving this thing up and down, so even though you might not be able to move it, doesn't necessarily mean that it's going to be that way when it's in the vehicle itself. Okay? Alright, tie rods consist of an adjustment sleeve in the center connecting to the inner and outer portions of that tie rod. Again, I'm saying tie rod as a general idea. Okay, it's one component, but we have to understand the tie rod actually has two different parts. Okay, we're going to have an inner tie rod, which is going to be right here, and then we have an outer tie rod, which is over here. Okay, not the greatest picture ever. So depending on how it's performing, okay, I could have an inner tie rod that's shot. This could be bad, which needs replacing. I could have an outer tie rod that's shot, right? That ball joint that I was just talking to you about could also be bad. In between the inner and outer tie rod is going to essentially be a threaded rod or a sleeve of some sorts. Okay, so I got a threaded section right here. That's threaded. This is threaded. And as I turn that inner and outer tie rod into that sleeve, again, I can either extend it to make it longer or I can bring it in to make it shorter. And that is how I do my toe wheel alignment adjustment. Now again, certain vehicles and certain manufacturers might have different setups in regards to how these are kind of put together. You're bad and you should feel bad. I have jam nuts right here that kind of hold everything in place. Essentially, we just got two jam nuts and we're kind of tightening those up so they oppose each other and they clamp onto one another. There's really no magic sauce in regards to that. If those jam nuts become loose, there could be a possibility of that thread working itself out or in, which could change your wheel alignment. Changing an outer tie rod end Not too difficult, typically speaking. I mean, again, we have to remove that from the steering knuckle, but then you just unthread it, thread a new one on, put that jam nut back in, put it in the steering knuckle, torque it up, and then we obviously want to make sure that we are doing a wheel alignment on that particular vehicle. Okay. We don't just simply throw it back on there and call it good. There must be a wheel alignment after we change any suspension or steering components. That is part of the service. Okay? I want to emphasize that. If you are changing out any suspension or steering components, there must be a wheel alignment after the fact. That's part of the service. Okay? So if the customer's saying, hey, I just need my outer tie rods replaced, awesome. Right? They're going to say, oh, how much is that going to cost? Make sure you put in the estimate a wheel alignment. And if they say, hey, I don't want that, be like, cool, go down the shop. We're not going to do this service without doing a wheel alignment. All right? It is a must. It is non-negotiable. And you need to educate whoever it is that you are potentially replacing this on why that's so important. It's not just for tire wear, it's also for the safety of the driver, knowing that they can go down the road straight. Okay. Again, any looseness on the tie rods, the joints, or the center links is going to call for a replacement of the parts. Again, if you can go in there and grab it by hand and move it around and it's loose, it is most likely going to be to the point where it's beyond its tolerance limit. Do you need to set up a dial indicator to make measurements on this? In most cases, no. But again, you want to make sure that you are checking the vehicle manufacturer specifications on what the vehicle manufacturer wants you to complete. What kind of tests, so on and so forth. Oftentimes, people are going to grab these tie rods or something and they're going to kind of shift it back and forth, like twist it in their hand. Okay? That's not always going to show you if it's in good condition or not. All right, we have to not just twist it, but we have to load it up through an axial or a lateral load. Okay, so that means we're going to run a little different test. Not just grabbing it and twisting it. Okay. And again, with anything suspension or steering related, if you have to replace one, it is recommended that you replace them in pairs. So again, if my outer tie rod on my driver's side is bad, I want to also replace my outer tie rod on my passenger side. All right, rack and pinion. This is a different type of configuration for our steering system. Okay, we've got parallelogram, which we kind of went through, Pitman arm, idler arm, center link, tie rods. Right? Those still have ball joints. And all that sort of stuff. Awesome. Rack and pinion. A little bit less in terms of the geometry complication. Lighter weight because it does have fewer parts. It's also going to be a little bit more preferred from vehicle manufacturers due to the fact that it is kind of all-encompassing, all-enclosed. So the wear and tear on these are typically a little less. But there are some common components and parts between a parallelogram system and a rack and pinion. Okay, so let me go and hold this up. Okay, this is our rack and pinion. This is what it looks like. Now obviously they come in different varieties of shapes and sizes, depending on obviously the size of the vehicle. Okay. Yeah, not super difficult.
What is that off?
I have no idea what this is off of. But what's remarkable is 2 bolts holding it all together.
That's
it. 2 bolts.
So I can go take Nathan's
The
off.
entire system is 2 bolts.
2 bolts. Now obviously you have your steering column, it goes to your steering wheel that you'd have to remove and replace, but
How do you move
this component is only held in place by 2 bolts. Okay? Kind of fun. There we go. Alright, anyways, rack and pinion steering linkage. Again, steering linkage. What's the definition of that? Between the gear and the knuckle basically. Okay, out to the tie rod, all of that stuff. So everything that I just held up would be considered steering linkage. It is lighter in weight, fewer components, and provides quicker response as compared to parallelogram linkage. So if I'm turning, it's going to respond faster. Parallelogram a little bit on the lazier end of things, not like it wouldn't be, responsive, but this is going to be much quicker because it's a geared system. As we shift, we can make more minimal inputs into the system and actually be able to make that as an output as well. Where a parallelogram system, I can make minor inputs and it might not translate. Something gets lost in the geometry on that. Okay, big important idea here. Rack and pinion steering systems. No idler arms. No pitman arm. No center link. Okay, but we do have tie rods. Tie rods are a universal component or part that's going to be on any steering system. Okay, and just like a parallelogram system, our tie rods are going to connect our rack and pinion to our steering knuckle. So as this is shifting back and forth, it's again turning that steering knuckle, shifting it left to right. Okay, why is it called a rack and pinion?
I'm gonna guess there's a rack and pinion.
Yeah, it's a part of a gear system, right? I mean, we could talk about interconnected gearing system. There's different types of like simple mechanisms that you've probably been taught. Can't remember much of them, but that's all right. Okay. Anyways, we have a small pinion that is attached to the steering column. As you rotate your steering wheel, that pinion gear actually rotates as well.
Hold on, what's a pinion gear?
Let me see if I can get my highlighter out here.
Picture.
Okay. There's the pinion. I don't know if I'm going to be able to draw this very successfully, but think of it like this. I've got like a rod here.
Like a long gear.
Okay. And then this has got teeth on it.
So it's like rotating the thing in the middle.
Yes. So this can rotate left to right. Okay, and these gears, or these teeth, are then going to be able to interact with a rack. Okay, a rack is basically a flat piece of metal that's got teeth on it like this. Okay, as this rotates around, those teeth are going to interact with the teeth on here, and it's going to slide back and forth. Okay,
I
so
kinda see it now.
this is the rack. This is the pinion.
And then the pinion would be horizontal.
The pinion is going to be attached basically
Are you getting this one?
No, yeah.
Yeah, I'm good.
Right
Like
now,
that.
Like in the picture,
Yeah, I'm ready.
the pinion is horizontal.
can I get a different color here? So in yellow is the pinion.
Yep. Right there's the rack.
There's the rack.
All right.
That rack goes all the way down.
And it just slides across that.
And that's basically, it's going to be moving back and forth based off of the movement or the rotation of your pinion.
Does the rack move on the pinion, or does the pinion move on the rack?
The pinion is held in place, and it's the rack that's shifting back and forth. Okay, if that makes sense.
Yeah.
Okay, now my tie rods. Okay, let's see here. My tie rods are right here. So here's my inner tie rod. Here's my inner tie rod on that side. So as this rack is shifting left to right, that tie rod is also being shifted left to right, which then again does the same performance as turning that steering knuckle back and forth. Okay? Boom, boom.
Yeah,
Again, in regards to understanding the concept of how the parallelogram system works and comparing it to rack and pinion, the center link on my parallelogram steering acts in the same manner that the rack is used for in the rack and pinion. Okay, center link shifts back and forth, the rack shifts back and forth. How we do that is just slightly different between the two systems, but the goal is still the same. Right? I still want to turn those steering knuckles to shift the tires so I can actually interact and cause the vehicle to do what I need to do. Anyways, the rack can be either end takeoff or center takeoff. That's not super important for you to know, but it's still out there. Okay, rack and pinion assembly is housed in a tube. It's all enclosed. On the ends, we've got some rubber bellows. Okay, some bellows. So again, let me go ahead and hold this up again. So I got a tube. Inside this tube is the rack, which you can't see. But then on the end, I've got some rubber bellow boots. So as this moves, I don't think I can move this. As this moves in and out, as the rack shifts, these bellows expand and contract.
So it's turning.
Okay, kind of like an accordion. There's bands on here that are clamping this bellows in place, so that way again, dust, dirt, water, salt, debris can't get inside here, which means my rack and pinion should be free from all those environmental contaminations. So ideally, this is going to actually last a much longer period of time. It's going to be more durable, so long as these bellows boots stay intact. If these are torn, cracked, ripped, just like our tie rod boots,
You can replace those?
we can replace these boots prior to trying to replace this. Yeah,
Why is one up and one's down?
and just the way that it interacts with.
Is it meant to be?
I had,
Oh,
there you go.
How much does that cost?
The whole thing?
Yeah.
Good question.
Oh.
Not too sure. The big thing is typically speaking, not super probably expensive. The problem is labor, because now I got to be able to get in there, disconnect my steering column, take out those two bolts, take out the tie rod ends, and then slide it out, which is not always easy to do on most vehicles, just because of the tight tolerances on stuff. More often than not, like for instance our Malibu, you're literally dropping the whole sub-assembly with the engine in it to be able to get access to that to get it off. So if you don't have the tools in order to do that, or the skills to know what to disconnect to be able to lower that, you're probably going to take it into a shop yourself. Anyways, those bellow boots are probably the best way to identify the rack and pinion steering system. Again, the expectation is when you go out into the shop and you are going to be inspecting steering and suspension systems, you are going to need to identify what kind of steering system you have. Is it a parallelogram or is it a rack and pinion? My biggest advice to you is find the tie rods that are connected to the steering knuckle and follow all that in to now where you can find the steering system. If it's got these rubber bellows, if you can see this attached to the tie rods, it's a rack and pinion. If your steering system does not have this, it's probably going to be a parallelogram system. Okay, that's the easiest way to do that. Find these. If it has it, good. If it doesn't, it's the other kind. Okay. Again, here's kind of a better look at what a pinion gear looks like and a rack gear looks like. Normally, again, you can't see those because it's inside that tube, away from, again, environmental contamination. Okay, like our parallelogram system, the center link is what determines the height of our tie rods and all that sort of stuff. So again, we're trying to prevent bump steer. On a rack and pinion system, we have a similar setup, but in this case, it's the housing that's bolted onto the frame that is going to determine that height, which then dictates how much bump steer we have. And again, as you saw, we've only got 2 bolts. Those 2 bolts is what's going to get bolted onto the frame to hold it in place. Okay.
So realistically, if somebody like went under your car, took those 2 bolts out, what would happen?
Well, you would probably still be able to steer, but it's going to be extremely noticeable before you even take off because, again, things are going to be very loose, rattling around. Things are going to want to shift back and forth. So a lot of that energy that you're transferring into the wheel is not going to make it to the tires.
So it'd be a long ride home.
it would be near impossible.
Without power steering?
Not even with power steering.
Oh.
You wouldn't be able to make it very far without noticing an issue, or able to probably steer. So that'll be a good thing because you're not going to get on the highway at this point. Prior to that. All right. Anyways, metal housing in the rack maintains the correct height of the steering components, similar to the way the center link, idler arm, and pitman arm do. And again, the whole idea behind that is to prevent bump steer. And we already talked about what bump steer is. Now, rack and pinion is not the only style in this particular type of steering system. It is the most common type, but you have to understand, I have a housing like this. Instead of having a rack and pinion, Mason and Easton, I could have one of these other types of systems in there as well. Worm and roller, worm and sector, worm and recirculating ball. Okay?
What's the ball
Just
one?
different ways of accomplishing the same goal. Okay? Again, they all have positives and negatives. So it depends on what the manufacturer wants to have in regards to how they want their vehicle to be steered.
Why does that one have a bunch of little balls?
Yep. That's the worm and recirculating ball.
Oh, is it like a bearing?
Yes, you could think of it as a bearing. Now, the reason why I'm telling you this information is not because I'm going to ask you a question on the test or anything like, oh, name all of these different types of rack and pinion systems. It's just to make sure that you understand that when you're looking at service information, you might look up rack and pinion and nothing comes up and you go, I know it's a rack and pinion. Mr. Ginsky says to look for the bellows. It has bellows. Why doesn't it have rack and pinion? It's because it could be a worm and roller, right? You're just searching for the wrong information to find the information you're trying to see. Okay? So just be mindful that there are different configurations even to this. All right, the steering column.
What was the last one?
The steering column has a lot of stuff attached to it. Okay? So,
And what is
part of our SRS system, safety restraint system like airbags.
warm and roller?
We also want to make sure that our steering column is collapsible. So in the event of a head-on collision, that steering column is not pushed into the driver. Obviously, I don't want to have that because that can cause significant or serious injury or death. Typically speaking, the steering column is not going directly into the steering rack or the steering linkage. Okay, the angle of that would be too steep. So your steering wheel would be up here like this, and you're turning the car like this. Right? That'd be awkward. It's very hard to kind of grip the wheel. Typically we want it like this so we can turn it like this. We have more leverage over that system. Okay? If I had the steering wheel like this, the steering column is actually going way in the front of my vehicle. So typically speaking, in most cases, we're going to have multiple U-joints, universal joints, and those U-joints are going to allow for that steering column to pivot and turn at varying different angles to be able to go from the driver compartment, steering wheel, down into the steering rack. Yes?
Could you accept my pass? Correct.
All right, steering column design differences include fixed column, telescoping column, tilt column, column-mounted transmission shift mechanisms. Airbags and electronic power steering are also mounted on the steering column. A lot of options on this. Okay? More often than not, we kind of have this thing where we have different people at different shapes and sizes. We want to make sure that as the driver, we don't know who's going to be sitting in our vehicle and driving in it. So we have to accommodate for these different sizes and shapes. Okay, my wife, for instance, is 5'2". When she gets in the van, she's got to have the steering or the seat more forward, and she has the steering wheel pushed up as much as possible, so that way she can reach the pedals and be able to drive very comfortably and without fatiguing and accurately. Awesome. The problem is I'm 6'1". When I get in the van, I can't be sitting in the same seat position. It's too close to the steering wheel. It's too close to the pedals. I have to back the seat out. Okay, I readjust it as it is, but part of that then is if in order for my legs to be able to reach the pedals comfortably, I am now reaching way too forward for the steering wheel. So in many cases, manufacturers are going to allow for telescoping motion, which means I can loosen this up and actually pull the steering wheel towards me, lengthening it, locking it in place, so now I'm comfortable. So I won't be fatigued when I'm driving the same vehicle. Okay, we also have different angles, right? I'm taller, so I want the steering wheel up a little bit more so I can have the right angle when I'm inputting that. She's a little shorter, so she's got to tilt that down a little bit more. Okay, it's always hilarious to me when you see like older grandmas driving a car and they're like can't even see over the steering wheel, right? Okay, it's not so much a fault of grandma, it's just the fact that we need to be able to raise her seat up to be able to look out, right? That's why a lot of people like SUVs, because you can see out further, and that allows you to be, I wouldn't say more predictable, but able to see encounters that you can avoid more easily. So again, a lot of things built into our steering columns to accommodate for this. Again, this is more for the driver. Okay, in the future, we won't have necessarily these the physical mechanisms that are linking the steering wheel directly to our rack and pinion steering system. Okay, there will be physically nothing between the two. Just like on most modern day vehicles, there is not a physical cable or system that's actually between your throttle pedal and the engine itself. Did you know that? When I hit the throttle on most modern day cars, all you're doing is basically sending an electrical signal through a sensor to the computer, and then the computer is deciding to actually open and close the throttle plate, which regulates the engine. Okay? Most of the time that's not advertised because it does make people a little nervous. But again, it's actually more accurate than a cable. Brakes are going to eventually get like that too, at some point in time. We're just not there yet, technologically speaking, where there will not be a physical connection between your brake pedal and the actual brakes themselves. It will be computer-controlled brakes.
Couldn't we have buttons then?
You can have whatever interaction you want. But Juan understands that after 100 years of driving vehicles, that's probably what most people have been trained on and what most people are used to. And if I want to sell the most type of vehicles, I'm going to try to make sure that my system is going to be compatible with the education of people. So I don't see a button being replaced anytime soon for braking systems. But it's kind of interesting the fact that you can think of, hey, I hit the throttle or the brake system, that sends a signal sensor to the computer, and the computer is going, yeah, I already know that. You're really behind the schedule here, and it's already probably braking and getting your ABS system ready to go to help slow you down. Again, this is the whole idea behind no steering wheels at all in our cars.
What? Then what?
Okay. Then the car drives up to where you get in the vehicle, and it knows where you're going because you probably put it in the app on your phone, and it drives you to the destination. Everyone will be a passenger at that point in time.
Who would be all the drivers?
You won't have any drivers. The car will be the driver.
I'm still driving. I don't really care.
You can't drive if you don't have a steering wheel. They won't have gas pedal or a brake pedal either.
No, like I'm gonna keep my car.
That's fantastic. Your grandkids won't.
Ooh.
No, right? How cool would it be right now for those of you that are not 16 years old? Hey, I want to go to my friend's house, but I can't drive. Car pulls up 5 minutes later, you hop in, you go to your friend's house.
That's sick. It's called Uber.
Yeah, it's called Uber, but the problem is you got people that are kind of a little sketchy on Uber, right? You got to communicate with them. It'd be nice just to be able to get in a vehicle, and it's like, hey, my friends want to go out to Milwaukee to do some kind of like video game convention. Awesome. You literally, boop, car pulls up, all of your friends get in the vehicle, it drives you down there. You say, okay, I'm going to get picked up at 3 o'clock. Comes, picks you up at 3 o'clock. Right? You don't even have to store a vehicle in your driveway or garage anymore. It's all subscription based. You won't own a car. Kind of crazy to think of.
You gotta think. Hold on. Should we think about what do you think your timeline on that is?
Do you think he'll still be alive?
Will I be alive? Yeah, I'm going to be pretty old on that case. I would say we're going to start. We've already started to see this system in place. It's not on a large scale event. I would say in about 20 years.
Okay, so in 100 years,
30?
there will be no more parking garages.
No need. Well, there'll be parking garages, but it'll be because of fleets of vehicles.
Just like little.
I'll be like 30.
I'm thinking like little bubble cars.
Yeah.
Like, what was that one movie? There was a girl. She was like a squid. She was
What?
red.
What are you doing?
You liked my beard.
What is he doing? He's not paying attention. That's what he's
Oh,
doing.
Wally?
Again, I don't want to get into it too much because again, that's kind of out there in the past. This last Friday, just so everyone is aware, last Friday I went to Wisconsin Dells for a training opportunity for automotive instructors in the state, and one of the things that we were discussing was this same stuff that I'm just talking to you about now.
You think 20 years will there'll be no more cars at all?
Yeah, by 2030 we're going to be seeing significant computer intervention on our vehicles.
Will there still be people driving?
Yeah, probably by 2030 for sure. Probably by 2040, it's going to be kind of split 50-50.
And then by like 2060, it'll be
2050, probably even. We're probably not going to see any vehicles that are being manufactured that are new. They'll have throttles, brakes, or steering wheels.
That's gonna suck.
You think so? But you know what people were thinking about when computers first came out? They're like, oh, this is going to suck. Now you guys can't even not look at your phone for more than 5 minutes. That's what sucks about it. It's going to get too good. It's going to get too good.
Yeah, what about like racing and stuff?
Well, let me ask you this. What did we do before cars?
Horses.
Horses, right? How many of you guys drove a horse here this morning?
Oh, that'd be sick.
Yeah, right?
That'd be
You guys had to take care of that horse? Feed it?
Feed it.
You got a barn, right? No one owns horses anymore. Guess what? How many of you complaining you don't have a horse? No one. No one here is complaining they don't have a horse, right?
I think people have
And guess what?
a horse. You have cars.
Before they raced cars, guess what they raced?
Horses.
Horses. Do they still race horses?
Probably some.
Absolutely. Have you ever heard of Kentucky Derby before?
Yep.
Yeah.
Gambling?
Yeah. Okay. So, what about racing cars? There's still going to be race cars, but guess where they're at?
Electric.
They're on a track like Road America. They're not going to be out on the road, right?
How about like the McLarens of the world?
All right. Power steering systems.
Like imagine buying a Bugatti and then everything just goes electric.
Yeah,
A
crazy.
self-driving Bugatti, bro.
My grandpa just bought a brand new truck.
Power steering systems reduce the amount of effort needed to turn the steering wheel.
2024.
Hi. I don't know why everyone's talking right now. I appreciate the fact that you guys want to have discussions about stuff, but when I'm hearing these conversations, it has nothing to do with anything I'm talking about. Okay, power steering systems. Before we had power steering systems, you literally had to crank the wheel and turn it. And the problem is at low speeds, those tires are going to need to turn and rotate and pivot. And when it's on a ground like that and the tire's not rolling, it's very difficult. It takes a lot of effort. A few years ago, I had a Ford F-150. My power steering system went out on that thing, and as I was trying to park the truck out in the school parking lot, it was nearly impossible to do. Because I'm in here and I'm putting body weight on it. Okay? And I'm not weak by any means. Okay? The thing though is again, just talking about my wife here for a second, right? She's 5'2", she's like 120 pounds. She's not built to be able to handle that truck when there's no power steering. She couldn't drive it. Okay? Power steering systems, Easton, are allowing us to have an assist on the turning of the steering wheel, so that way there's less effort. Again, there's less fatigue from the driver as they're driving down the road. I could literally take one finger and I could spin my steering wheel. Okay, back and forth. So that way my full concentration can be on everything around me, not by, am I going to make the corner?
How do they have cars
Okay.
with no power steering? How do they even do
This is back in the day. You just had your normal steering linkage systems, right? With no assist. Now, in most cases, we're using a hydraulic system. So as I'm turning my steering wheel system, there's an actual little motor,
Like a freak.
like literally a pump that's hooked up to my serpentine belt, that's hooked up to the engine, right? This spins, which creates hydraulic pressure, which then runs through these lines, and these lines are hooked up to my rack and pinion, or in some cases, my parallelogram system. That hydraulic pressure is then utilized as a force to assist in turning the steering wheel. Pretty simple system. Okay? On more modern day vehicles though, again we have rack and pinion as our main steering system, we are going to have an electronic motor do the same thing. Okay? We'll get more into that probably on Wednesday. So we got about 4 minutes left here. What I'd like you to do is, before you pack up your notes, go through what you wrote down, review the information. All I need you to do is, I need you to just write 3 questions. 3 questions. Based off of what we talked about. I know we talked about future cars not having a steering wheel. Maybe you have questions about that. Maybe you have questions about current modern day systems. Or maybe you have questions about older systems before we had our modern amenities.
How did you turn your horse in?
Okay? So that's how you go with that.
What kind of steering system does a horse have?
Yeah, the horse is the steering system.
But you horses have back in video.
But that's a good question. All right, we're at the presentation at this point, or at least the recording.
Outro. Don't. You gotta hit your outro.